Welcome back. So this video, we're going to talk about some things to watch for when thinking critically about data and statistics. There's a tendency, I think, when people see numbers to go, oh, this is objective, right? And often we'll shut off our critical thinking at that point. So this will just be a couple things to always keep in mind when somebody gives you a statistical argument or a claim about what data has said to you. In, I think we live in a environment where large language models and generative algorithms and algorithmic approaches to data analysis are more and more common. So I think these kind of, I guess, reasoning errors or reasoning deficiencies are going to be more common and things that we have to pay more attention to, right? Some of these are really obvious, but again, none of this is necessarily overly complicated. It's just really easy to ignore and make pretty significant errors if you do ignore, right? First thing to think about is when you're looking at data is this a representative statistic, right? I think that's the single most common way that statistics go wrong is by failing to represent. A statistical argument has to do two things, right? It must be made from a sample that is sufficiently large enough to justify the claims that people are making, and then it must appeal to a statistical set that represents the target group. And we often fail to do that, right? And the second somebody throws a number at you, we don't think and go, well, where did this number come from? How was it generated? Often people want data because, again, stats have that kind of compelling, oh, well, I can't argue with that. That's what the numbers say, right? So often companies, often executives, often politicians will generate a data set or a stat so that they have this kind of bullshit that is more compelling than like a simple argument will be, right? So you often are looking at unrepresentative statistics when you don't think you are. So we have to be careful about that. Politicians are notorious for being in this business, right? Again, often what political parties will do is they'll set up a survey and they'll go to their base or their voters and then they'll be like, tell us what you think. And then they'll get a number and they'll say something like, 86% of, people in the province or the state think we should separate or think we should have privatized healthcare or whatever. But they're only looking at they're not looking typically at a representative sample of the population at all, right? So that number is meaningless bullshit. In fact, it's manipulative bullshit, right? It's not representing what voters actually believe. It's a very targeted group of people that are saying what this politician wants them to say, are then giving them data that they can then show to you and say, oh, look, everybody thinks this way. And then you, as the voter that doesn't really want to privatize healthcare, right? That's compelling and coercive, right? It's the kind of thing that will nudge you and go, well, I'm just one person. I guess if everybody wants that, maybe I should think that way. And then they can change your political beliefs, right? So that's why people do stuff like this. So often people will produce biased statistics out of bad faith. Corporations and will do this because they want you to buy their products, right? Politicians will do this because they want you to think certain ways. You should always be very careful. Think tanks often are set up with political ideologies, right? That's different from academia, right? Like in academia, when we're operating at our best, people are arguing in good faith and they're producing data that is impartial, right? When somebody produces a stat, you should think who funded it, who generated that data. Sometimes you're funded by research organizations that have agendas, right? Often private think tanks are funded because they're supposed to promote certain political ideologies, or they're promoted by private citizens or corporate donors or special interest groups that again want certain things to be the case. And if that's the kind of source funding a statistic, we should be really, really careful. Are they generating their data in an impartial way, right? Are they publishing results that go against what they, what their stated aims are? Or is everything that they're publishing supportive of their particular position? Sometimes, private interest groups will operate in good faith, but more often than not, the data that you're getting is biased. It's not the kind of thing that you should, yeah, at best, it's the type of stuff you should take with a grain of salt. So, always, is it representative? Do they have a sufficiently large enough group to justify the claims that they're making? And is the group that they're looking at genuinely representative of the target? If you want to know, say, what the people of, I don't know, Michigan think, you need to look at a representative sample of the people of Michigan. And that needs to include all the people, right? So it's got to be a large enough group to get the opinions of that target, which is the people. Can't be just, say, college students, can't just be white people, can't just be old people. It's got to be the representative sample of the group you're talking about. So we often go wrong that way. This is particularly important too to look at when you're looking at older research in academia. So there's this thing called weird people, right? One of the problems, particularly in the social sciences, really through most of our history, is that most of the work that academics have done has been done on weird people. What we mean by that is people that are white, that are educated, that live in an industrialized, democratic society, right? People that are rich, that are wealthy, right? So the average subject that social science has been conducted on in the 20th century has been university students, right? It's been professors and the people in their classes. And the people that have gone to universities have tended to be weird, right? They've been white, they've been educated, they've grown up in industrialized democracies, and they've been wealthy, right? That's not representative of humanity, which is usually the group of people that we want to talk about when we're doing research, right? And so there's been this bias in general in much of the really famous research right across the social sciences is the audience that they did their research on were statistically weird. And so the research is not representative. This is a problem people became aware of not that long ago, about 30 years ago. And so one of the projects people have been doing in academia over the past couple decades is just trying to get non-weird groups of people, right? So they've been going and they've been redoing classic studies and trying to get representative samples. They're trying to figure out, do results change if we do them on groups that aren't weird? And oftentimes they do, right? So that's something to be careful about, right? Even well-intentioned people, it's really easy to have an unrepresentative sample when you're doing research. So, or when you're generating a statistic. Sometimes you got a statistic that looks like it should be obviously, like a data. I don't know. Like it's true, say that most CEOs at Fortune 500 companies in the year 2000 were men, right? I'm sure the data says that. And then we find out that we've got a CEO and their name is Frida, right? Would it be reasonable to think that Frida is a man, given the data? Even if our data told us that, say, 90% of CEOs at Fortune 500 companies are men? Well, no, it wouldn't be, right? Because of the context, right? And we all know that, right? It'd be really odd for Frida to be a man, which might be, but highly unlikely, despite the statistic, right? So even if somebody's giving you a statistic, there might be contextual or things about this particular case that say this is an exception to that data. Even if the data really strongly speaks one way, we should ignore the data in this case, right? Or we do have a really compelling reason to ignore it. Related to all this, whenever somebody shows us data or stats, we should know the source. And I've talked to this, right? We should go, who generated the data, why? We should be looking at, are we looking at a primary source or a secondary source? Did they go to those primary sources, right? Are they representing the data well? Again, this is something politicians do all the time, right? And probably companies too, but they have money at risk, so they're sometimes less likely to do this maybe. But you might get statistics that say one thing, and then you go, that's nice. And then you go and you just say, actually, the data says something totally different, right? So you might think of a provincial government that's often in the business of doing that. They will get data that says one thing, and then they will go out and they'll say, well, actually, Albertans or people want this to happen. And they'll then start promoting exactly the opposite position of what the data says, right? But they'll act like, well, they've done their research and they have the data that backs up their claims. But if you go look at the data will literally say the exact opposite of what they're wanting to do. Uh, that happens all the time, right? So just because a politician or somebody says, "Hey, we've got data, we've got stats, we're making data-informed decisions, and this is, and so we're acting on this," go look at the data. They might just be an idiot and not know how to interpret their data, or they might just have done the research and then not like the fact that the research says do something other than what they want to do. Another really important thing to think about when you're thinking about statistics and data in general is what was operationalized, right? Um, a lot of the things we want to know about and a lot of the things we study are not straightforward empirical observation, quantifiable kind of things. Like if you want to know if you work in a good place to work, or the degree program that you are studying in has good results for students. You've got a normative concept there, right? And you've got a kind of, and you've got a fuzzy concept, right? You've got something like what does it mean to work in a good place, right? To have a good work environment. And we all probably mean different things by that, right? Some of us want a really good work-life balance. You want a boss that, you work 9 to 5 or, and there's no emails there at 2 in the morning. Others want a lot of flexibility in their schedule, right? So maybe for some people, the good workplace, really strict 9 to 5, no exceptions. Whereas other people, the good workplace is one where they can do their 12 hours of work anytime they want to, right? Even if it's at 4 in the morning. But if they want to leave the office at 2 in the afternoon for 30 minutes, they can, right? They both have a different, both of those are good workplaces. They just mean totally, they're just understood in totally different ways, right? So if I'm now kind of try to get data that tells me whether or not my workplace is good, well, I've got to find a way to operationalize the concept of good. And it's got to be operationalized as something I can quantify or measure, right? So I've got to have some way of going to my data set and then pulling out people's opinions. So what I'll do is I'll operationalize it, right? So again, going with our workplace example. So our company will go, okay, well, what does a good workplace mean? And then they'll come up with a bunch of features. It's one where people are happy with their pay, one where people feel like they have good work-life balance. Make a list, right? And again, a lot of the times those concepts themselves are subjective or can be operationalized in different ways, right? Again, work-life balance can mean a whole bunch of different things to different people. So they'll do that and then they'll go look at data, right? So then maybe they'll go do a bunch of surveys of their employees. Do you think you have good work-life balance or whatever? Or they'll get an algorithm to go do this or something like that. They'll generate a data set now, right? That is the operationalization, that is a measurement of what they've operationalized as good, right? And then they'll have that data and they'll go, oh, we found that 72% of the employees at our company think that they work in a good this is a good workplace to work at. Um, is that relevant to you? Well, it depends on what they mean by good workplace, right? Um, we should always be careful, right? That the thing that's been operationalized actually means the same thing as the type of thing that we're studying. Maybe they just mean like by good workplace that the employees are productive, right? Or no employee has tried to kill themselves in the past week at work, right? Um, so we should be careful about that, right? Very often the way in which we operationalize a term does not in any interesting sense measure the thing that we're talking about. Um, So that happens. Sometimes that's malicious. More often than not, it's really difficult to measure qualitative concepts and normative concepts, right? And so the way in which you operationalize something often either conceals or misrepresents the thing that we're measuring. So we should be very careful about this, particularly when it comes to stuff like values. Worth noting when you're thinking about data, right? That mean, median, and mode are not the same things. When we talk about an average, we could be talking about any of those things, and you should be really careful that the average that the person's using is the same average that you have in mind. Okay. One other thing I want to talk about is p-hacking. P-hacking, again, in the age of big data is a really big concern. And this has been another area where we had massive problems in the social sciences that people are just starting to grapple with. So when you have a data set, you can change the well, you can p-hack, right? What this is when you modify your data analysis until you're able to produce a statistically significant result from that data, right? You think about algorithms and algorithmic decision making, right? It's really easy to modify an algorithm or for, an algorithm to learn to modify itself so that it gets statistically significant results from that data set, or results that are, it can report back to the user as something they should be care about. Because again, an algorithm is typically just wanting to produce, something that will please the user in some way. We'll talk about that in a second. But with p-hacking, what you're doing is you've got some data, and then you are changing your value of statistical significance until you see a result in the set. There's lots of ways to do this, but the most notable is notable is changing your measure of statistical significance until you have a result. This compromises the veracity of the claims you make about your research, right? It undermines scientific integrity when you p-hack. It allows us to prove or disprove any claim we essentially want from any set of data, right? Which makes what we're doing sort of meaningless, right? If we allow p-hacking in our domain, right, then what we're doing is we're making numbers radically subjective. And this is increasingly a problem in an age of big data because people with little to no understanding of statistics or little to no understanding of how, generative algorithms or LLMs work or are making data-driven decisions on the basis of data sets and metrics, right? It's increasingly a problem in an academic world where we must publish or perish, right? Where professors are constantly rushing after that next publication, or graduate students are trying to get enough publications under their belt to get a job, right? If we have data, we don't want to just leave it. We want to do something with it to get a result that we can publish. These kind of things can happen, intentionally. They can also happen unintentionally. Where we don't have time or need to go too deeply into this issue here. We just have to be aware of it. The main ways in which p-hacking are going to occur is when we have what we call a type 1 error. That's where we get false positives. So we get a compelling result from the data, even though there shouldn't be, right? This drug works, right? And a type 2 error is where we have a false negative. This drug doesn't work, right? There's lots of other things we can do here. But again, what we're doing, right, is we just have our data. So you get your data, and then you have to decide what is statistically significant. What result are we going to take as, this is something we should pay attention to, right? If you raise the bar and you make it harder to get a statistically significant result, then you're going to have false negatives, right? You're going to miss things, right? You're going to have things that are important that you're just not paying attention to from the data set. If you lower the bar, right, you p-hack in that way, you're going to have results that are not worth paying attention to, that you should pay attention to, that you shouldn't be paying attention to, right? But we can move that bar, and that can change the way in we interpret data. Now, you're an executive, you don't understand anything about statistics, you got a data set, and then you want to know which employees should be fired. You just move that bar of statistical significance around, and you get a whole bunch of people that probably shouldn't be, right? That kind of stuff. This came to light as a really, really big issue during the replication crisis of the 2010s, right? So in 2015, Science, one of the leading journals, right, published a study that showed that 64% of the top 100 experimental results in psychology conducted over the 20th century couldn't be replicated. This is a replication crisis. That's a big deal, right? Because if you've got a science, one of the key features of a science is that when you do a study, people can replicate it. They can go do what you did and they'll get the same results. And what they're finding here is that most of the results in psychology, most of the big results in psychology were not replicable, right? That means that, and that's huge, right? This implied that there might be a less than chance possibility that anything your psychology professors tell you is true. Or at least there's a more than chance possibility that everything they're saying is not supported in any interesting sense by empirical data. And then that result was generalized right across the social sciences and even to parts of biology, to parts of the natural sciences, even to parts of information science. And when you go get away from the academic fields and you get more into the applied stuff like education or business research, right? Or corporate research, or, then things get worse, right? And that was what the replication crisis was. It was a big deal. And what this led to in psychology in particular, but just right across academia, not so much in the corporate world, but definitely in the academic world, was a change in standards, right? It led to people being much, much more rigorous about what counts as statistical significance. It became to people publishing null results. So when you get a study and nothing happens, nothing interesting happens, there's journals now that'll just publish that. This helps people get publications that need publications. It also helps keep people honest about their data, right? It minimizes the amount of p-hacking that goes on. And people started just going back and replicating. I talked about weird people. This is the other side of that problem, right? People went back and they did robust replications of everything that had been done in psychology. And this has spread to the other social sciences. Psychology actually rapidly became the gold standard for how to do statistical research. Because this is a serious problem. It undermines the field. Data science, arguably, with its tech bro move fast and break things attitude, I think is yet to seriously grapple with this issue. They're too busy moving on. So, lots more we could say about this. General point when it comes to data, when it comes to statistics, is be very careful with numbers and with data. You can and should speak back to them. Don't think that a number is somehow more objective or more factual than an argument. It's not often the case. Often the thing we call data or stats are more squishy and up to more interpretation and are even more subjective or more your personal truth than the claims you might find in a poetry class. So stay skeptical.